Hey, welcome back to another edition of Mr. Wernau Does Your Homework For You. So we're going to take a look at worksheet number 2 on the first fundamental theorem, and we're just going to sit here and work a bunch of questions together. Hope you guys don't mind. Hang on. Alright, so let's take a look at question number 2 first. Now, this looks kind of weird. The area from 2 to 5 of this 2f of x plus 3 is 17. And they just want to find out what is the area from 2 to 5, just what is the original area the function is equal to. So although it looks confusing, this is really just like an algebraic problem. So I am just going to expand our function, or rule here. This is going to be 2 times the area 2 to 5 f of x dx plus, do the same thing with the 3 of the area from 2 to 5 f of x, whoops, just 2. That's just dx right there. And then they want me to set this equal to 17. And they want me to find out what is this equal to. Now the first thing I have to do is I have to take care of this little bit right here. Now there are two ways I can solve this one. One, there's a 1 there. I could integrate that one. Or I can just look at this as a rectangle. There's a 1 there. This is just a rectangle from 2 to 5 that has a height of 1. I know that the area there is just going to be 3 by 1, which is 3. But you've got to be really careful. There's another 3 on the outside, so this is really saying plus 9 equals 17. So what I'm left with now is 2 from 2 to 5, f of x dx, and now I can just solve it like an algebraic question. Therefore, the area from 2 to 5, f of x dx is going to equal, subtract the 9, I get 8, and then divide by 2, we get 4. And there's our answer. Super easy to do. Alright, so let's take a look at number 3 here real fast. Given region A has an area of 1.5. Now they're never going to tell you this, but remember, A is really negative 1.5 because it's below. And the whole area is 3.5. So we have to find the region of from 2 to 6. So if I want to find the region of 2 to 6, well, we could just break that down. That's our geometry problem. That is just region A plus region B. Look, that is B. That's terrible in arithmetic. So if I want to find this, if I take the whole area, 0 to 6, f of x dx, that's going to equal the parts of it, right? Region A plus region B. Well, I already know that this is 3.5, and A, we know, be careful, is negative 1.5. How do I find B? Yeah. We just add them, and that becomes, what's that become? 5? Is that right? Check my math on me. I'm never really right on arithmetic. Now the next one says, well, what's the area from 0 to 6? But be careful here. Remember, this says all y's positive. So anything below becomes positive. Well, that's just going to be the absolute value of A plus the magnitude or absolute value of B. So that becomes 1.5 plus B, which is 5. I get 6.5. Very easy to do these. All right, these are fun, man. All right, let's take a look at number 6, the calculator question. 5 and 6 are both calculator questions for us. This says water is being pumped into a holding tank at a rate. So if you notice, they're giving us this rate here. And that is a derivative. So chances are, if they give us a derivative, we're going to have to integrate. Where t is in minutes since the pump started. The holding tank contains 1,000 liters of water when the pump is started. So they're giving me the initial value here, some initial value. How much water does it hold in 1 hour? Be very careful. We're talking minutes, so we're looking at t is 60 here, by the way. So I'm looking for a value, so we must integrate. So this is our FTC step. And to do this, we're going to take the integral between 0 and 60, because that's our time. My function's in terms of t, it's a rate, so I'm going to call it r of t, dt. And that's going to equal the value at 60 minus the value at 0 here. If I keep going, I'm going to integrate this using my calculator. I don't know that antiderivative there. So if I got my calculator here, first things first, doc B, kill the memory. All right. So if I type this in my calculator, menu, there we go, wrong button. the integral from 0 to 60, and that's going to give me my function 5 minus 5 e to the negative 0.12 x. Now last time I used t, but I'll use x this time. Just make sure the variable matches up there. X. I press enter, and I get this 258.364. Now remember what this means. This is the change in volume. So this is, we've gained 258 liters of water. So, and that's going to equal f of 60, write this out, minus f of 0, which we do know is 1,000, because that is my value at 0 right there. That's my initial value. I'm starting with 1,000 liters. So how much do we have in the end? Well, I just add that 1,000 to the other side. We get 1,258.364 liters. Now, how do I know that's going to be liters? Well, look at the units. Remember, this is liters per minute. Time is in minutes. You look at that, used for chemistry, and we get our liters right there. Our liters. Take me to your liter. Oh, man, I never was good at the metric system. All right. Part 7. Now, we're only going to do one of these for Part 7, but you'll kind of get the idea here. This is actually how we, the AP will sometimes employ Riemann sums. So they're giving us the values of the derivative on the table, and they tell us the initial value f of 0. We want to estimate f of 2 using a right Riemann sum. Anytime they say Riemann, we're looking at rectangles. So to get f of 0, or f of 2 here, I'm going to look at the region between 0 and 2. They're giving me my derivative. So the area under my derivative is going to give me my function. Take a look. I'm going from a derivative to a function. We need antiderivatives. That's how we find them. If I'm going from a derivative to a function, we need antiderivatives. So to get f of 2, f of 2 would be from 0 to 2, f prime of x dx. And I'm going to set this up. My FTC, this is going to be f of 2 minus f of 0. So, but to get this one, since I don't have a function to plug in, I am going to use my Riemann sum. Right there. So, from 0 to 2, it tells me to use a right Riemann sum. 2 is on the right, so we're going to say this whole area there is 18. So that's the whole area, so the height there is 18. The area is 36. So this is basically saying we're going to get 36 equals f of 2 minus f of 0, my original, 100. And therefore, f of 2 would be 136. And I could do one more. Let's do f of 4. If I want to find f of 4, same thing. I can say this. Now, watch what I'm going to do here, though. I'm not going to start at 0 this time. I'm going to start at 2. From 2 to 4. F prime of x dx, because I know that value at 2. And that's going to equal f of 4 minus f of 2. I'm always going to put down my chart here. And if I do the area now, between 2 and 4, that's the only part that I'm interested in right now. Between 2 and 4, 4 is on the right. It has a height of 23. So we're going to think this whole area, which has a base of 2 and a height of 23, the area there, of course, is 46. So this is now saying my area, which we just said was 46, equals f of 4 minus f of 2, which we said was 136. So therefore, f of 4 is just going to be 136 plus 46. Don't tell anybody. I can't do math to save my life. Plus 46. Oh yeah, 182. And you can keep going that way to get 6. So why don't you guys go and try that one real fast, okay? All right. So that's the end of part 1 of Mr. Wernau Does Your Homework. Come back, we'll do a few more.